First sum, x1 of n is equal to 1, 2, 3 minus 1. Find x1 of z. Okay, they have told you to find the z transform of this x1 of n. Alright, so how do you find x1 of z? Simple, right? x1 of z is given by the formula summation n is equal to plus infinity infinity x of n z raised to minus n. Alright, now where does the signal exist from? Origin is over here, right? So this is minus 1, this is minus 2, this is plus 1 and this is plus 2. So my signal exists from, summation exists from n is equal to minus 1 to 2 x of n z minus n. Alright, so so n has different values, minus 1, 0, 1 and 2. So I will just expand this for you. For value of n as minus 1, first value, let me just expand this summation. For first value of n as minus 1, x of minus 1, z of minus 1 is plus 1, plus next value of n is 0, x of 0, z raised to 0, right? Next value of n is 1, x of 1, z of 1, minus 1, sorry. Next is for n is equal to 2, x of 2, z raised to minus 2. Okay, what is x of minus 1? Value of x of n, okay, that is x1, sorry, we are talking about x1 over here, so x1, okay, x1, we have x1. What is x1 of minus 1? Value of x1 of n at n is equal to minus 1, so that is 1, right? So this is your minus 1, 1 plus x of 0 is 2, z of 0 is 1, plus x of 1 is, x1 of 1 is 3, z minus 1, x1 of 2 is minus 1, z of minus 2. Therefore, what can you say? x1 of z is equal to z plus 2 plus 3 z inverse minus z minus 2. This is your answer. Okay, and what is the ROC of this? Yeah, we have seen this earlier. ROC of a finite duration signal is what? It is the entire z plane. Okay, so ROC is the entire z plane. Second sum, x2 of n is equal to half raised to n u of n minus half raised to n u of n minus 2. Okay, only find the ROC, don't find the z transform. Fine. So what can I say? I can see half raised to n common over here, so I will say half raised to n u of n minus u of n minus 2. Okay, what is u of n minus u of n minus 2? I think by now you should be able to do it. U of n. What is u of n? U of n is a step signal. What is u of n minus 2? A shifted step, starts from 2, 3, 4, right? What is u of n minus u of n minus 2? So 1 minus 0 is 1, 1 minus 0 is 1, and then 1 minus 1 is 0, and so on. So only 2 samples, right? So this is what this is, 2 samples. Okay, so the same as half raised to n. Okay, so what values of n? N is equal to 0 and for n is equal to 1. Right? So u of n minus u of n minus 2 gives us 2 samples. So this x2 of n is only for 2 samples, 0 and 1. So what can I say? This is a x2 of n is a finite duration signal. Therefore, what is ROC? ROC is entire z plane. Okay. Next sum, please. x3 of n is equal to 5 by 6 raised to n u of n plus 6 by 5 raised to n u of minus n minus 1. Alright. So what is our formula which you have seen, standard formulas? A raised to n u of n is 1 upon 1 minus a z inverse, that is z upon z minus a. What is ROC? Mod z is less more than mod a. And what is the next thing? Minus of a raised to n u of minus n minus 1. What is it? Z upon z minus a mod z less than mod a. Fine. We'll use the same thing for this sum, x3 of n. So I will have x3 of z. I'm taking the z transform. Okay. A raised to n u of n. Here a value is 5 by 6 plus a raised to n u of minus n minus 1. So you can use this formula, right? So what is the value of a over here? 6 by 5. A raised to n. So a is this, a raised to n. A raised to n. What is missing over here? A minus sign is missing. So I will add a minus sign over here, and to negate the effect of minus sign, I will add one more minus sign over here. So what is my answer then? A raised to n u of n. So a is 5 by 6. The answer of this is z upon z minus a. Z upon z minus a. A is 5 by 6 over here. Very careful. Minus, okay, this extra minus which you have added now, minus a raised to n u of minus n minus 1 minus. So you will have z upon z minus a. What is a over here? A is 6 by 5. Okay, this is it. This is the answer. What is to be seen over here? The ROC. What is ROC? Mod z is more than, right? Because why more than? Because it's u of n. More than a is 5 by 6. And over here, what is ROC for this? Mod z is, yeah, it is u of minus n minus 1. So it is less than a is 6 by 5. Okay, let us plot the ROC now. How do you plot the ROC? First you must plot the unit circle. Okay, where is the first pole? First pole is at z is equal to 5 by 6. So 5 by 6, is it more than 1 or less than 1? This is 1, right? So 5 by 6, is it more than 1, less than 1? It is less than 1, somewhere over here. 5 by 6. My first pole. Where is the next pole? It is at 6 by 5. 6 by 5 is more than 1. So 6 by 5 is over here. Alright. So what does the first ROC says? First ROC says that mod z is more than 5 by 6. Means the ROC should be somewhere like this, something like this. More than means like this. And the next ROC I will do by green color. Mod z is less than. Less than means you should not have the unit circle. It should be like this. Less than. Be very careful with more than, less than. Okay, I am not able to draw the circle properly, so please do it properly in your exams. Mod z is less than 6 by 5 means it should be inside like this. Okay. So what is the intersection, please? What is the intersection? Intersection is, what is the intersection? This entire yellow region which you see now. Okay, this entire region is the intersection of the two ROCs. Only at these values, these points, is my Z transform going to exist. Okay. So what is my final ROC? I can say mod Z is more than 5 by 6 and less than 6 by 5. That is my final ROC. Alright, I hope you have understood this. Okay, just one more small question. Will this signal x3 of n be stable? Yeah, it will be stable. Yes, because my ROC contains the unit circle which is here in red. So ROC has the unit circle, therefore stable. x3 of n is stable. Okay. Last sum for this. X of z is equal to 1 upon 1 minus 1 by 3 z inverse into 1 plus 2 z inverse. Plot ROC for different cases. You have to plot the ROC. That is the question. Plot the ROC for different cases and obtain x of n. Alright. So first things first, x of z is given to me in this format. I cannot deal with it further. I need to have partial fractions. A upon 1 minus 1 by 3 z inverse plus b upon 1 plus 2 z inverse. I will equate this to this. Therefore, 1 upon 1 minus 1 by 3 z inverse into 1 plus 2 z inverse is equal to a upon 1 minus 1 by 3 z inverse plus b upon 1 plus 2 z inverse. Therefore, I will say 1 is equal to, I will just cross multiply this with this, a into 1 minus plus 2 z inverse plus b into, I will just cross multiply this entire thing with this, okay, with each individually, 1 minus 1 by 3 z inverse. How do I find the value of a and b? To find the value of a, what can I do? I can make z inverse as 3. If z inverse is 3, this thing goes away, right? Z inverse is 3 cuts, this thing goes away. So I will have 1 is equal to a 1 plus 2. What is z inverse? 3. Therefore, 1 is equal to a 1 plus 6. Therefore, a is 1 by 7. Similarly, if I want to find b, what do I do? If I want to find b, I will put z inverse as 2. If z inverse is 2, not 2, 1 by 2. Z inverse is 1 by 2. This 2 will get cut. It should be minus 1 by 2, minus 1 by 2. This will go and I will just remain with b. Okay. So 1 is equal to, this thing cuts away because z inverse is equal to minus half. We'll cut this and make it 0. I'll say b 1 minus 1 by 3. Z inverse is minus half. So 1 is equal to b 1 plus 1 by 6. Therefore, b is equal to 6 by 7. Okay. So I can say for x of z is equal to 1 by 7, 1 minus 1 by 3 z inverse plus 6 by 7, 1 plus 2 z inverse. So let us start off with case 1. Let us say x of z is this. If you take inverse z transform, you will get x of n. So first case, x of n is a right sided signal. Okay, right sided means u of n. I'll take the inverse z transform of this. So x of z will give me x of n. 1 by 7 upon 1 minus 1 by 3 is z inverse. So what do we have with us? We have a raised to n u of n has 1 upon 1 minus a z inverse is equal to z upon z minus a. So what do you find? I can use this thing. I can use this. So I will say 1 by 7. It's a constant. 1 upon 1 minus 3 z inverse. 1 upon 1 minus 3, 1 upon 1 minus 1 by 3 z inverse. What is a value? A value over here is 1 by 3. So it is 1 by 3 raised to n u of n. So 1 by 3 raised to n u of n will give me 1 upon 1 minus 1 by 3 z inverse plus 6 by 7 is constant. I need to find what is this value over here. Okay, so 1 upon 1 plus 2 z inverse, 1 upon 1 plus 2. What is the value of a then? Value of a is minus or minus 2. So value of a is minus 2. Minus 2 raised to n u of n. Be very careful with this. It is minus 2 raised to n. So minus 2 raised to n, minus 2 raised to n will give me 1 upon 1 minus minus of 2 z inverse. Then we get this answer. Why have we done u of n? Because we are assuming signal to be right sided signal. What is the ROC for this? Mod z is more than a. What is a? 1 by 3. And mod z is more than minus 2. Fine. Let us plot the ROC, please. Fine. So, what is the pole value over here? It is 1 by 3. What is the next pole value? It is minus 2. Fine. So, what are they saying? Mod z is more than 1 by 3. Mod z is more than 1 by 3 means a circle will be over here and should be more than that. And mod z is more than minus 2. More than minus 2 means it should be in this way. So, what is the combined of this? Combined of this is mod z is more than minus 2. So, my final ROC will be like this. Mod z is more than minus 2. What is ROC? ROC is like this. Okay. This is my final answer for case number 1. So, mod z is more than minus 2. Good. Next case, please. Case 2. X of n is left sided. Means u of minus n minus 1 I should have. Okay. What is my formula saying? Formula is minus a raised to n u of minus n minus 1 is z upon z minus a is equal to 1 upon 1 minus a z inverse. Okay, same thing. Okay. So what is missing over here? I am saying x of n is left sided, so it should be u of minus n minus 1. Okay. So what is missing over here? A minus sign is missing over here. So I'll add a minus sign over here, and to negate that, one more minus sign. Again a minus sign over here, negate that, one more minus sign. Okay. Now I will take the inverse z transform. Therefore x of z is x of n is equal to minus of, so this minus I will use, minus of 1 by 7, and I will use this term over here, minus of 1 upon minus of, I will take the minus sign over here, minus of 1 upon 1 minus a z inverse. Okay. So what is the answer of that? A. What is the value of a? We have seen 1 by 3. 3 raised to n u of minus n minus 1 and minus 6 by 7. For 1 upon 1 plus 2 z inverse, 1 upon 1 plus 2 z inverse, same thing, minus 2 raised to n u of minus n minus 1. I hope you have got this. The ROC of this is mod z is u of minus n minus 1, right? So less than a is 1 by 3. Over here, mod z is less than minus 2. Let us see how the ROC looks like. This is my unit circle. Mod z is less than 1 by 3. So 1 by 3 is my first pole and 2 is my next pole. Sorry, it's minus 2. Okay. So mod z is less than 1 by 3. Less than means inside, less than 1 by 3. And mod z is less than 1 by minus 2. So something like this. So this circle over here and this circle. So this less than means you will have a ROC like this, and this is like this. What is the combination of less than this and this? The answer is going to be mod z is less than 1 by 3. Right? So this is the final ROC for this. Less than minus 2 means this inside and entire thing inside, and less than minus 3 means this thing. So combination of both is only this part over here. That is my ROC for case 2. Now if I check case 3, x of n is two-sided. Okay. So what I can do is, I can assume this to be right-sided. I will assume this to be left-sided. Okay. You can take the opposite and check also. So if I take inverse z transform, x of z is x of n, 1 by 7. What is the value over here? We have done this earlier, 1 by 3 raised to n u of n. Since this is left-sided, so I will have to add this extra minus sign over here, minus of 6 by 7 minus 2 raised to n u of minus n minus 1. Good. So what is ROC over here? Mod z is more than, right? Because it is u of n, more than 1 by 3. And over here, and mod z is less than because u of minus n minus 1, less than minus 2. If I draw the ROC, my unit circle, mod z is more than 1 by 3 means the first pole is over here, next pole is over here, minus 2. So more than 1 by 3 means like this, more than 1 by 3, and less than minus 2 means minus 1, and so on, like this. So this ROC is less than, this ROC is more than. So what is the combined value? Combined is this shaded part over here. Okay. What is the combination of these both? It is mod z is more than 1 by 3 and less than minus 2. Fine. I hope you are understanding. So pole was at minus 2 over here and 1 by 3 over here. Fine. If you do the opposite, you will get a case where x of n does not exist. X of z 1 by 7, 1 minus 1 by 3 z inverse plus 6 by 7, 1 plus 2 z inverse. If I write this as right sided and this as left sided, let us see what happens. Okay, inverse Z transform, what is going to happen? X of Z is x of n. If I make this as right sided, so I will make this left sided, right? Left sided and right sided. So left sided means I should add extra minus over here. So minus 1 by 7, 1 by 3 raised to n, u of minus n minus 1 plus 6 by 7, 2 raised to n of n. What is the ROC for this? Mod z is less than, right? 1 by 3. What is the ROC for this? Mod z is more than 2. So if you draw the ROC, let us see what happens. This is my unit circle. Poles are at 1 by 3 and minus 2. What is the first pole? Mod z is more than, less than 1 by 3. So mod z is less than 1 by 3 means something like this, less than 1 by 3. What is mod z is more than 2? More than minus 2? More than minus 2 means something like this. Okay. So both the ROCs over here don't intersect. ROCs do not intersect. What is the conclusion? Therefore, conclusion is Z transform does not exist in this case. Okay, very, very important. Fine. So a sum like this comes often in your exam. Please take care of the sum, plot the ROCs for all the different cases and obtain the corresponding x of n. Okay, so this ends your Z transform sums from normal basic formula method. Next we'll see properties and then we'll finish off some more portion of Z transform. Okay, yeah, thank you.